Hello everyone, welcome back to our platform. In this lecture we will study inner products and norms. हमने जब लीनियर ट्रांसफॉर्मेशन को डिस्कस किया था देन वी टॉक अ फंक्शन फ्रॉम वेक्टर स्पेस V to V some another vector space as well. Then we have talk about some special kind of functions which are from V to F और इन्हें हमें बोला था linear functional. Now in this particular session we are going to discuss those functions F which are defined from V cross V to the field F. Okay. Now whenever we have an element from V cross V type structure we call that as an ordered pair. तो basically ये जो functions हैं इस तरीके के वो ordered pair के लिए define है और जो भी resultant value आएगी that will be an element in the field. अब इस तरीके के जो फंक्शन है जब ये कुछ पर्टिकुलर प्रॉपर्टी को फॉलो करेंगे तब हम इन्हें बोलेंगे इनर प्रोडक्ट. ओके और इसको डिनोट करेंगे हम इस नोटेशन से. Okay, x comma y with in between these two symbols. Okay, so let us start the definition first कि किस तरीके से और कब हम इस तरीके के functions को inner product बोलेंगे. So definition and this definition defines inner product. Okay, so this definition says let V be a vector space over F and F is filled. Okay, and inner product on V, inner product on V. Okay, we will not call of V in V. Inner product on V is a function that assigns to every ordered pair of vector x and y in V a scalar in F denoted by x comma y. Okay, such that for all x comma y in x comma y and z in V and for all c in F the following hold. Now the first one is जब भी हमें किसी फंक्शन को इनर प्रोडक्ट प्रूफ करना है तब हम इन चार कंडीशंस के बारे में ही सोचने वाले हैं और उनमें से पहली है दैट इनर प्रोडक्ट x प्लस जेड और y इज सेम एज इनर प्रोडक्ट x कोमा y प्लस इनर प्रोडक्ट z कोमा y. Then B part says inner product C or C time x comma y is same as C time inner product x comma y. Whenever this kind of property is followed by some structure we call that linear. Okay, so you can see our inner product is linear in first component, we call this as first component, this is second component. So inner product is linear in first component. Then third condition is that x comma y conjugate, this is complex conjugate, okay, is same as y comma x, where this bar, okay, where bar denotes the complex conjugate. And then D condition says if our x is not equal to 0 then inner product x comma x is always is a positive real number. Okay, so this must be strictly greater than 0. So these are the four condition which has to be satisfied by a function in case we want to prove that function is inner product. Okay, so let us discuss some examples so that we can identify कि ये सब किस तरीके से काम करता है. Okay, so first example is about standard inner product. Okay, so in first example we will prove a function और उस function को हम inner product के रूप में देखेंगे and then we will call that function as standard inner product. Okay, so let me write that standard inner product. Okay, so example, let me convert this into an equation. So let Fn over F be a vector space for all x comma y belongs to Fn. Define inner product x comma y is equal to summation I running from 1 to n ai and pi bar. Okay, where this x is nothing but the n tuple, where x is equal to a1, a2 and so on an. Okay, and this y is equal to b1, b2 and so on bn. So these are element in fn. So we are defining a function, this one. Okay, show that this function dot comma dot is an inner product on fn. ठीक है, so let me write the solution first, then we will discuss something new in this particular answer. So given that for all x that is equals to a1 comma a2 comma and so on comma an and y equals to b1 comma b2 comma and so on bn in fn x comma y is given as summation I is equal to 1 to n ai bi bar. So what we are doing here कि हम यहाँ से x से फर्स्ट कंपोनेंट ले रहे हैं और b के y के फर्स्ट कंपोनेंट का कॉम्प्लेक्स कंजुगेट लेके उसका मल्टीप्लाई कर रहे हैं. देन इसी रिजल्टेंट क्वांटिटी को वी आर एडिंग इन दी मल्टीप्लीकेशन ऑफ a2 एंड b2 बार. सो वी आर टेकिंग द रेस्पेक्टिव कंपोनेंट ऑफ x एंड y और इस तरीके से हमने ये एक फंक्शन डिफाइन किया है. अब हमें इसको इनर प्रोडक्ट प्रूफ करने के लिए चार प्रॉपर्टीज को सेटिस्फाइड करना है. ओके, सो लेट मी कॉल इट एज 1. ठीक है, सो टू prove that 1 defines an inner product on fn, we follows the below discussion. Let me write the first one. So first is about in the first one we need to write an extra element. So let z that is equals to say c1 c2 and so on cn be an element in fn. Okay, then we know the addition in n tuple So x plus z will looks like a1 plus c1, a2 plus c2 component wide addition, right? So on we have an plus cn. Okay, so if we have the addition, so we can write x plus z comma y. The same is हमने कैसे लिखना है इसको? We will write the sum I running from 1 to n and choose the elements ith element in x plus z. So the ith element will be ai plus ci, then choose the ith element in y and take its bar, so bi then bar. Okay, now this addition, or you can say this addition and multiplication, is in complex space, so we can say this is equal to summation I running from 1 to n, and we can distribute this multiplication as ai bi bar plus ci and bi bar, right? Now the summation can be distributed as well. The summation I running from 1 to n ai bi bar plus summation I running from 1 to n and ci bi bar. And by the definition you can say this is nothing but x comma y, and this is nothing but z comma y. Okay, so let me write. So hence x plus z comma y is equal to x comma y plus z comma y, and let me denote it by 2. Okay, now come to the second one, b, and for that we need to assume some scalar. Let c be any scalar in f. Okay, then what will be c times x? So this is nothing but c of a1, c times a2, and so on, c times an, right? Then what can you say about the about defined function c times x comma y? So that is nothing but the summation of I running from 1 to n, and you need to choose the first element from cx and then take the first element from y and uh, take the bar of that first element of y. So I am writing this ci, this is the ith element, this is the ith element from y and the bar of this element. Okay, now you can see this c is free from this index I. सो कैन वी से कि हर एक एडिशन में इस सम के हर एक समेंड में दिस सी विल बी अ कॉमन फैक्टर, सो आई कैन टेक आउट this c from this summation. So we can write this as c summation I is equal to 1 to n and ai bi bar, and by definition this summation is nothing but c times summation x comma y, right? So you can have, so you can write that summation c x comma y is equal to c times x comma y. So this was the second condition and it is followed by our function. Now in the c part we need to identify the conjugations. So you just write directly x comma y bar is same as summation I running from 1 to n ai and bi bar and then a whole bar. नाउ क्योंकि बार तो एडिशन पे डिस्ट्रीब्यूट होता है, दिस इज नथिंग बट द एडिशन, सो यू कैन से बार ऑफ एडिशन इज एडिशन ऑफ बार. सो व्हाट डू आई मीन that I is equal to 1 to n and you need to take bar of the summends. So this will be sum. So what I'm saying, bar of sum is equal to sum of bars. Okay. Now this is equal to, you can say summation I is equal to 1 to n and we can write this as ai bar and bi bar of bar. Okay. You have that. You have this one, okay, in the complex number z1 z2 bar is equal to z1 bar and z2 bar, and z1 bar of bar is same as z1, so I am using that one. So you will have this is equals to summation I is equal to 1 to n and ai bar bi. Now this multiplication can be also written in our non form, that is bi and ai bar, and this is nothing but by definition y comma x. So you can write, so we have that x comma y bar is equal to y comma x, and hence the third condition is also satisfied. Let me call it 4 and the previous one was 3, so that at the last we can write from 1 2 3 4. This is an inner product. Okay, now let x that is equals to a1 comma a2 comma and so on an is not equals to 0, and when we have that some n tuple is not equal to 0, that means at least one of a1 a2 an is non-zero. Okay, that is at least one of ai's is नॉन जीरो, और जब भी हमारे पास कोई नॉन जीरो नंबर होता है तो इसका स्क्वायर और यू कैन से उसका मोड वैल्यू हमेशा पॉजिटिव ही होता है, और यही कंसेप्ट हम यहाँ पर यूज़ करने वाले हैं. ओके, सो देन what can you say about x comma x? So this is nothing but summation I is equal to 1 to n and take the ai and ai bar, and we know z bar is same as mod of z bar mod of z square. So we can write this is equal to I is equal to 1 to n, and this will be mod of ai square, right? Now you can see at least one of these ai is zero, non-zero, so that square mod square will be strictly greater than zero. अब हो सकता है सारे ही जीरो हो, बट एक हमारे पास नॉन जीरो है और उसके अलावा सारे मान लेते हैं जीरो है, तो उस केस में भी उस नॉन जीरो वैल्यू की वजह से ये पर्टिकुलर नंबर हमें एक पॉजिटिव वैल्यू देगा. सो आई कैन से दिस इज ग्रेटर देन जीरो. ओके, सो you can write that if x is not equals to 0, then x comma x is strictly greater than 0. Okay, so let me write this as 5. Okay, so thus from conclusion from conclusions 1 2, okay, 2 to 5, this the function which one, this comma this is an inner product on fn known as the standard inner product. Okay,